Okay, so we are on page 23. We're looking at average rate of change, and we can see two graphs at the top of the paper. So you first learn rate of change. You first learn that sentence at the very top. I'm pretty sure that's you first learned. Yeah, rate of change. So write down the word change as slope. Which the shortcut for slope, or like the easy way to remember it, was rise over run. Which is really the change in the y values over the change in the x values. So we first learned rate of change as this, as slope, rise over run. The fancy way of saying it is the change in y over the change in x. So our graph here is depicting two people, a man and a lady, driving to Seattle. So the man obviously has a very straight line. The lady is like all over the place. So we are going to compare the rate of change between the two people. So the first one is we're going to look at man's. So find man's rate of change for the given intervals. Now let's remind ourselves what these intervals mean. So we're going to get an interval, and the first number we're going to call that A, and the second number we're going to call that B. What that means is we're checking from where X is A to where X is B. So that looks like a 6, but it's a B. So when it says, check the man's rate of change from 0 to 2, what they mean is from X is 0 to X is 2. And we're just going to do this as rise over run, or change in X over change in Y. So we start at 0 on the X, and we go to 2. So I'm just going to draw a line up to the man's graph at 2. And then I'm going to draw that over to the y-axis so that I can see how far he went. So what this box is now telling me is that he has driven 100 miles, that's your rise. He has driven 100 miles in the past 2 hours. So he went 100 miles in 2 hours. How do I know? Because on the X, I go from 0 hours to 2 hours, and then I increase to 100 miles. You're hanging in? Okay, so now let's change that. What's 100 divided by 2? 50. So the first 2 hours, he drives 50 miles per hour. Okay, now they want us to check from 2 to 4. So this time, I draw my line up to the man's graph. Then I draw over to the Y. What does it mean that the two graphs are crossing right here? Do you guys know what that means? So this means at this point, the man and the lady are in the same spot. The man and the lady have both driven 200 miles an hour. Okay, to calculate this rate of change, you need to look at only this space. We're only going from 2 to 4. So you want to look at the increase in the space that I have lightly highlighted. So remember, we do this as rise over run. So we increased from 100 to 200. So what's your change in Y? What's your change in Y? 100. If you go from 100 miles to 200 miles, you increased by 100 miles. Over the run, well, we went from 2 hours to 4 hours, so how much did that change by? 2. Okay, once again, what does that simplify down to? 50 miles per hour. So the first 2 hours, he went 50 miles per hour, and the second 2 hours, he went 50 miles an hour. Okay, well, now let's look at it overall. So now they're saying, forget about these lines that we drew and calculate how far he went overall. So now that's the entire shaded region. So down here, this is 0 to 4. So I took out that little box, and now I'm going to look at 0 to 4. So it's rise over run. We have gone from 0 all the way up to 200. So this time your change in Y is 200. Because we started at 0, and at hour 4, we're at 200 miles. What's our change in X? We started at 0, and when did we stop? 4 hours. So what goes in the bottom? 4. What does he simplify down to? 50 miles an hour. So this man must have had on his cruise control because his rate of change is constant. And this is what you guys focused on in 9th grade, constant rate of change. This is a constant rate of change. And the reason that it's constant is because the graph is linear, meaning it's a straight line. Any straight line has a constant rate of change. That is your slope. So the slope for this entire graph is 50 over 1. Well, in 10th grade, all of a sudden you guys started learning a bunch of curved graphs. So your graphs go from straight lines to curved lines. All of the ones that we just did to review domain, all of them were curved except for absolute value. So let's look at how that changes the rate of change. So I'm going to erase all the stuff that I wrote for the man so that I can do this, the same thing for the lady. And on the ladies, we have some points that are going to help us determine where we're going. So we're doing the same intervals that we did for the man. So the first one is 0 to 2. So on the lady's graph, she has a point at 2 to help us know that that's where we go. Now we want to take that over as best we can to the y-axis and get an estimate of where we think we're at on the miles. Okay, how high do you guys think that is? Fire? 75, I would agree. I think that's very close to 75. So the lady traveled 75 miles in the first 2 hours. She traveled 75 miles in the first 2 hours. So what's her rate of change? So take 75, divide it by 2. Plug it in. You should be typing things, because I doubt any of you are doing that in your head. Diamond. Thanks, babe. 37.5 miles per hour. Okay, now they want us to go from 2 to 4. So it's going to look similar to what we did for the man. We're going to take our graph up from X is 4 all the way to where her line is. And then we're going to drag it over to the Y. So now they're asking about that space, just like they did for the man. So we go from 75 to 200. So what is that difference? 75 to 200. Think about it like money. 125. So that goes in the top of your fraction. And then at the X, we moved from 2 hours to 4 hours. 2. So what is that one? What's that rate of change when you simplify it? 62.5 miles an hour. So the first 2 hours, she was going pretty slow, and then she probably realized she needed to pick up the pace, so the second 2 hours, she goes almost twice as fast as she was going. Okay, now let's look at her overall rate of change. So this one, I take out that little box that was 0 to 2, and I look at the overall change. And hopefully you guys are noticing that that looks exactly like the man's did, because the man and the lady are at the same place at hour 4. So how far did they both travel overall in the first 4 hours? 200 miles over 4 hours, and that would give us 50 miles per hour. So when you have a straight line, your rate of change just stays the same the entire time. But when you have a curved line, your rate of change depends on what part of the graph you're looking at. So in some areas, she's driving 37 miles per hour, and then in other areas, she's driving 64. But overall, she ends up in the same place as the man because her rate of change was different. Sometimes she went slow, sometimes she went fast. So part of what led me to come up with this example is because this is how me and man really drive. He uses cruise control everywhere. I did not even know people use cruise control that much. Do you guys use your cruise control? I never use it. He uses it all the time. So he would get there doing 50 miles an hour the whole time, but I would just be all over the place. Okay, so now let's relate this to the types of rate of change we are going to look at. So now we're on page 24. We're going to calculate the average rate of change for different functions, and we're going to need a formula that's going to work for all functions. So we need a formula that's going to work for all functions. So he looks kind of crazy right here, but really he's a lot easier than he looks. So this is the same thing as rise over run. These fancy letters, F of A and F of B, is describing what happens on the y-axis, and B and A are describing what happens on the x-axis. B is where you end, A is where you start, and this will all make a little bit more sense once we actually do some problems. So just to reiterate, this is the same thing as saying, what is the change in the y over the change in the x? So remember, functions can be represented by graphs, tables, or an equation. So we just looked at a graph. Our first example of average rate of change was a graph. The next two that we're going to do are tables, and then the last one on this page is an equation. And then the last thing that they want to remind you of is that your intervals can be written as an inequality, like a less than equal to x less than equal to b, or just an interval a to b. That's a lot of information, but this is, I promise you, it's not as overwhelming as this might seem. So find the average rate of change for weight lost at Weight Watchers from week 1 to week 4. So week 1 they weigh in, week 2 they weigh in, week 3, week 4. We want to know the average amount of weight that they lost over the 4 weeks. So that means that your A is week 1 and your B is week 4. Okay, well, I can indicate that I know that on my table by going and highlighting what is in those spots. So in week 1, I have a weight loss of 5 pounds. And in week 4, I have a weight loss of 0.7 pounds. So what this table is telling you is that this is A, this is B, because remember, those are always the X values. Well, if this is A, then 5 has to be F of A. And if this is B, then 0.7 has to be F of B. So now I have every single thing that I need to use this formula at the top. So I'm going to rewrite the formula. You guys don't have to, but I'm going to rewrite it just so that you can see it on the screen as we fill it in. So for F of B, what should we fill in? 0.7. For F of A, we should fill in 5. Make sure that you minus them. In the bottom, we plug in B, the ending point, which is 4, subtract 1, which is the starting point. So then if I'm using Desmos, I can just click on the Desmos, come up here. I like to use their calculator. I can just hit the backspace button and plug it in exactly like I see it on my paper. I can plug in 0.7 minus 5, arrow down, plug in 4 minus 1, hit enter. And this is telling me that the average rate of change was 1.4 pounds per week. Why is it negative? Because we lost weight. We're going to Weight Watchers, so we lost weight. So this is telling us, on average, we lost about 1.5 pounds per week. Are you hanging in? Okay, let's do the next one. So this is average rate of change for Pete's height from 3 to 5 years. So I'm going in order of how they give it to me on the prompt. So A is 3, B is 5. So now I come and match that up in my table. 3 matches 37. 5 matches 45. Which means that if this is A and this is B, then the bottom is f of A and f of B. So at 3, the function is 37 inches. At 5, the function is 45 inches. And now all we have to do is plug it into this formula. So f of B would be 45. F of A is 37. Make sure that you minus. B is 5. A is 3. You can plug that all in as one big fraction. Most of your calculators will do it. Desmos will do it. I'm getting 4. So the average rate of change was 4 inches per year for Pete. Okay, on your whiteboard, I want you guys to do 2 to 6. And I want you to write the fraction on your whiteboard. So I want to see blank minus blank over A, B minus A. They're right here. Oh, okay. I thought you was throwing away your marker. Is 20 seconds enough? No. Maybe let's try 20 and see where you're at. About 10. Five. 3. 2. Okay, show me how far you got. So good. 35 inches. That seems very big. 3.5. Thanks, Ivani. 3.5. I lied. Do you want to do one more table?
Yes.
Yes. Okay, just turn your book over. And I want you to find out how many calories or what is the rate of change from week 4 to week 5. So this is a tiger cub. These are the amount of calories that he needs to eat in the first 5 weeks of his life, I think. So I want you to tell me what the rate of change is from week 4 to week 5. And write it in your book too. You can just write the answer on your whiteboard if you want. Okay, about 10. Five, 3, 2. Okay, show me. Okay, this is 100. My work is right here. Okay, one more. I promise you it'll be worth it. Let's check from 3 to 4 this time. So this time do week 3 to 4. So this one was 100. Now I want you to check to see what it was from 3 to 4. This will be the last table that we do for a minute, not forever. Okay, about 20. $10. 5. 3. 2. Okay, show me. 135. So from week 3 to 4, his amount of calories that he needed changed more. Okay, so now I'm going to show you how to do this with an equation. Then we'll practice a couple and you'll take your quiz. So notice this time you have inequality notation, but it works about the same as before. So 1 would be your A, that's your starting point. And 10 would be your B. So I just flipped my notebook back. So now what I need to do is plug these two values in this function that they give me right here. So I'm going to say when A is 1, I have to find f of 1. So that's this function, 2 raised to the power of 1. What does that equal? 2. Okay, then the next one we do is B, which is 10. That means we have to find f of 10. So that's 2 to the 10. Thank you. 1024. And now you guys have everything that you need for the fraction. So f of b is 1024. Subtract f of a, 2, over b, yep. Does it turn out to be a nice number or a horrible number? Ugh. So I'm just going to put 113.8. You can put 113.7 if you prefer. Is that what you guys got? Oh, I didn't minus the 2. So this should be 113.5. I forgot to subtract the 2. I just did 1024. I didn't do 1024 minus 2. Okay, now you guys try that for the next one. So I'll help you set it up, but I want you to do most of the work. So they give you the same interval, 1 to 10, but a different function. So you have to find f of 1 and f of 10. Yeah, that's what your A and B is. You guys are plugging those in, yeah? Give about 20 seconds and then I'll check in with what you got on these. Not overall, but just on those. Okay, what was f of 1? F of 10? Okay, when you plug this guy in, make sure that you're really careful to plug in 93 minus -6. You got to be really careful on that one. You can just change it to a positive if you know that that's the shortcut. But I usually just leave it as 2 negatives. Okay. It's a little extreme. What did you guys get? Oh, 9.6 is not right. I also got 11. So in this case, I just recommend that you leave it as the minus negative. Last year I was teaching this during distance learning, and one of my students emailed me and said, not to criticize your teaching or anything, but you can turn 2 negatives into a positive, just in case you didn't know. Son, really? Really? Okay, so I want you to do 5B. Do 5B on your whiteboard. Do 5B. You can skip A and C, but do 5B. Just in case you didn't know, he said. Whiteboard. Well, you can just write your answer on the whiteboard if you want. Ten. Five. 3, 2. Okay, show me. Is he negative or positive? He's negative. This guy is negative 7.5. Okay, my last question is, for the Tiger Cub, what week was the change in calories the largest? So you have to find week 1 to 2, and week 2 to 3. And then tell me what week had the biggest change. So you got to find week 1 to 2, and then week 2 to 3. And then compare these 4 numbers that you have. Is 30 seconds enough?
Yeah.
Okay, you got about 10. 5. 3. 2. Okay, show me. Week 2 to 3. So from week 1 to 2, it increased by 175, but then 2 to 3, it increased by 185, then 135, then 100. So week 2 to 3 had the biggest change in calories. You're okay? Okay, your quiz is in Canvas and your module is showing.